The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Great. Now we'll take a moment here and quickly take a look at Henry's Law. Let's start here with a definition. Henry's Law: a dissolved concentration of gas in a solution is proportional to the pressure of the gas over the solution. Now, a perfect example of Henry's Law is when we open a can of soda. When we open a can of soda, bubbles of carbon dioxide gas come out of the liquid, and that's because the pressure of the carbon dioxide within the can decreases. Thus, in turn, the solubility of the carbon dioxide gas also decreases. Now, if we want to find the solubility of the gas, we can do so through the following equation, where we have the solubility of the gas, right? And here we have Henry's Law constant, as we see, and the partial pressure of the gas over the solution. Great, let's take a moment now and take a look at figure 5.4. Now, if at equilibrium, right here, we're going to have equal amounts of gas particles going in and out of the solution. Now, if we press down on the piston and we increase the pressure, then momentarily we're going to have more gas particles going into the solution than we do coming out of the solution. Thus, when we increase the pressure, right? When we increase the pressure, as we see here, we're increasing the solubility of the gas. Now, that occurs until we reach a new equilibrium. And that is what is being depicted here in figure 5.4. Great, let's do an example now of Henry's Law on the next slide. Example, Henry's Law. A gas has a solubility of 0.75 molar with a partial pressure of 5 atmospheres. What would the solubility of the same gas, what would be the solubility of the same gas at 8 atmospheres? Great. We see here at 5 atmospheres we have the following solubility, right? And that was at 5 atmospheres. Great. Now we're being asked for the solubility, at 8 atmospheres, right? And we'll call that here S2. Wonderful. Now this problem here is fairly simple. It just requires a little bit of equation manipulation. Great. Beginning here with our equation that we just introduced to find the solubility, because our gas is going to be the same gas at 8 atmospheres, we can use the following equation, right? Where we just take our solubility over the pressure, which is equal to the solubility at our second pressure. And now if we just isolate for the value that we need, right, that being the solubility at 8 atmospheres, we end up with the following equation, where we have over the partial pressure of the initial solubility. Now let's go ahead and fill in our values and see what we attain here. Just cross this out, that way it doesn't get confusing for us. We have the solubility at 5 atmospheres, which was as follows, right? And we have our partial pressure at 8 atmospheres just make that a little bit neater for us. There we are, over the 5 atmospheres, right? And once we go ahead and we equate this, we find that the solubility value is going to be as follows. There we are. Great, let's now move on to our next slide.